All right, Physics 2, welcome back to part 2 of Monday's lecture. We're going to be introducing chapter 21. So this is the first of the last 3 chapters of your book that we have really been building towards all semester. So you're going to be talking about patterns of fields in space. All right, so we know a couple things about electric charges. We know several things about them, actually. They're really cool. They produce both electric and magnetic fields. Of course, they need to be in motion to produce a magnetic field. And we're very comfortable calculating or estimating the magnitude and direction of the fields due to different charge distributions. Okay, so basically what we've been doing so far in this chapter, or in this whole Physics 2 series, is thinking about the electric fields as they relate to different charges. Now we're going to be thinking more about the fields themselves, which is actually the more important of the two concepts. So, what we're going to be doing in this chapter is how to observe a field pattern and infer a charge or charges. So if you observe a field, what does that tell you about the cause of it? And this, from a practical point of view, is actually the more realistic of the two scenarios. So, and to do this, we are finally going to introduce Gauss's law. So what this will do is it relates patterns of electric fields over closed surfaces to the amount of charge. So that is the crux of Gauss's law and what it does. So, and just a heads up, I take my own approach to introducing Gauss's law. I somewhat follow the book. I deviate from the book. So just, in other words, use your book, read the chapters, recognize my notes aren't going to follow the book as closely as they have in other chapters. All right, so moving on. And where I am following the book, you'll see that I'll be writing the headings up top, and then where I deviate, you'll just kind of see nothing. So patterns of electric field, which is going to take us to Gauss's law. All right, so the big question we have is, what's in the box? So let's play what's in the box. And all that we have is the field lines. So we've got a box, and let's say we've got a field that's radiating out. So we can't open the box, we can't see inside. All we can measure is this field. So can't open, unknown contents, only can measure field. All right, so what do we know makes positive, or I just gave it away, that radiates its field lines outwards? Why? That's a positive charge. So you could safely assume that perhaps there is a positive charge in here, or a collection of positive charges. That would be consistent with the field lines that this box is producing. So outward pointing field lines, likely a positive charge. Remember, positive people radiate their positivity outwards. Okay, so let's look at another box. So here we have another box. We can't open it, unknown contents. And we've got a bunch of field lines all being directed into the box. So what could possibly cause this? Well, just like positive people radiate their positive energy outwards, negative people have a way of drawing all the attention to themselves, just like negative charges. So this is likely a negative charge, or a collection of negative charges, or a collection of charges where the sum total is negative. So we know something about what's in these boxes just by measuring their arrows. We know about the direction of field lines. We can use that to learn about how to reason what types of charges are in different situations. All right, so pretty easy. Let's move on. Now, what about this box? So we've got field lines that look like this. So they're going through the box. What is inside? This one's a little bit trickier. So there might be a charged positive plate on the left, or a negative charged plate on the right. So that's one possibility. So maybe we've got a positive plate here and a negative plate here, maybe. That seems kind of weird. But what is most likely is that there is no charge in the box. So this box likely exists inside a wire with a uniform electric field. So what we can see here is that sometimes there's more than one explanation. So you have to think about which one makes the most sense. And we'll be building towards how to do this through some calculations as well. All right. So what about this box? So we have field lines pointing out on either side, nothing on the top or bottom. So one explanation a large positive plate could be dissecting the box. Making an electric field. So if we had our positive plate, then it would be radiating lines out like this, which we would measure outside of the box. All right, so you're starting to get the hang of exactly how we play this game. We look at the field lines, we think about what we've already learned about the directions of them, and we make inferences about the cause of the charge inside the box. So even before we start introducing calculations, your first thought is conceptually, what do I know? What do I know before I calculate? Okay, so to build on this further, I need to introduce the concept of closed versus open surfaces. So, and this is really vital to understanding Gauss's law. All right, so far what we have been looking at is we have been looking at closed boxes. So, and in this case, this would be really realistically a three-dimensional, poorly drawn closed surface. And we can conclude a lot about looking at this enclosed three-dimensional surface. So what about, say we just had a plane and field lines like this. All right, so there's a lot of different things that could be causing field lines like this. So this is not the same as a three-dimensional closed surface. So this would be an open surface. So many possibilities. And so when you enclose a particular surface within a shape, preferably an easy to calculate shape, you can learn more about it. So this is the main reason why we need to make sure we're differentiating between closed and open surfaces. And Gauss's law typically has to do with a closed surface. So, all right, so we're going to be building on closed surfaces. So we're going to be expanding our idea of closed surfaces. All right, so Gauss's law is for closed surfaces, and it's going to give us the relationship between charge and field. And to do this, we need to talk about flux. All right, and so I will introduce flux in our next lecture. All right, I will see you then.